Okay, we are straight up making opposites on problem number 3 here. So just like the last one, we didn't have opposites, but we had the potential for it, because once you have opposites, you can cancel them and then add the remains. So we don't have opposites. So this is going to be kind of an aggressive move for you all, but you're going to make them. Okay, so just like you can use -1, you can use any number you want to make opposites. As long as you multiply every part of the equation by that number you choose, it'll be okay. So the question now is this: should we make opposite x values or opposite y values? 2 and 7 don't have a lot in common. 5 and 15, totally. I always like to take the smaller number and scale it up to be the opposite of the bigger number. 2, you can't really do that with a 2. 2 doesn't go into 7, 7 doesn't, yeah, they go, ooh, 5 and 15, they're kind of related. Man, if I could just triple this, I can make opposite. Then do that. If that's all you need to do, then just straight up do that. That's what they do right here. They take everything times 3, look what they get. Okay, they take the 7x, the -5y, and the 17 times 3. They also kind of restack it, because when you multiply and you restack it, everything lines up all nice and neat like. Cancels, combines, combines. One-step equation, 19x equals 19, boom, x equals 1. Once you have one of the variables, use it to find the other one. Again, x and y will rat each other out. So there you go. You have x, plug it in, find y, there's your solution, okay? So what would we do here? Let's take a look. We have a -5x and 3x. We have a -2y and a 6y. Probably not going to make opposites very easily there. 5 and 3 don't have much in common. 2 and 6, they have a common factor, I believe. Yeah, so let's do that. Now, how could I make these guys opposite? One's got to be negative, one's got to be positive. That's okay. So I probably want to just go ahead and multiply this by 3. I'm going to go ahead and do that. Take that whole equation times 3. I'm going to rewrite it and restack it. So I'm going to have a -15x. I'm going to have a -6y, opposites, and then an 18. By the way, don't pay attention to these two 6's. It's okay for different looking equations to equal the same number. So don't freak out. Oh, those are like terms. I should know. Just ignore those. Only care about the variables, please. Cancel. See you later. 3x plus a 15. X is going to be a -12x. Okay, 18 and then a 6 together is going to be a 24. Man, this looks pretty tricky right here. Divided by -12, divided by -12. X is going to equal a -2. I got one, so let's find the other one. Let's make sure I'm answering the questions here. How can you use the multiplication times 3? Write and solve the revised system on it, and then show the solution. Show that the solution of the revised system is a solution of the original system. So it's basically asking, if you put x and y into the original parts, would you get answers? Yeah, I would. You can double check my work, but I'm pretty confident I'll be okay. All right. So eeny, meeny, miny, mo. Catch a tiger by his toe. If he hollers, then just be nice to him because he's an animal. Put a -x in either of these. I'm going to pick the middle one there. So I'm going to pick the 3x plus 6y equals a 6. -2, you're going in right there. 3 times a -2 is a -6 plus a 6y equals a 6. Good thing my Lisp isn't getting me too bad today. Shouldn't make any mistakes here. Oops, divide by 6, not a 0, bruh. There you go. -2 and 2 is going to be my solution. Okay, again, if you don't have opposites, then make them. This is a very aggressive mathematical move, but it is way more efficient than substitution. Also, you can double check with Desmos. Graph these things really quick and see where they lie. Okay, so either you are using opposites or you're making them to use them. All right, opposites are the best way. They cancel, and elimination is a pretty cool move. All right, peace out, bye.